lot of you are going to be attending different parties, gatherings with your friends and family. And now you have a whole bunch of different illusions you can see if they can do.
Yeah, some of these are good party tricks.
Yeah, right. That's why we saved it for Friday. So it was fresh in your brain. So one more minute and we're going to see if Mr. Sheik is ready at the Franklin Institute.
Hey, can you guys see me, everybody? If you guys can see me, because we're about to start very soon.
Yes, we can see. It looks like we're going to be learning about liquid air, guys. All right, if everybody's not back, if you want to come on back, we're going to get started at the Franklin Institute in just a minute, okay? Who's excited? I'm excited. All right.
Hello, good morning and welcome everyone to the air show in the Muster Demonstration Theater in the Franklin Institute. How's everyone doing today? Excellent. Thanks for joining us. Is this anybody's first time here? First time visiting? Let's see, a few people. Quite a few people. Okay. Right. Well, that's good. That's good to see because this show, this liquid air show, I like to think of it as our most famous show. I want to give you a little bit of a history lesson here. This building that you're in was built in 1934. So it's been here for about 89 years. The liquid air show that you're watching today started in 1934. So it's been going on for as long as this building has existed. This show is our longest running science show here at the museum. We've been doing it for a long time. I've also been doing it for a long time, not that long, but long enough to know that we cannot start the show without a very special ingredient. So I want to know who thinks that ingredient is air. It makes sense, right? But wait, who thinks maybe instead it might be liquid? Wait, let's get more advanced. Ready? Who thinks it's liquid air?
Yeah, liquid air.
Even more sense. But no, it's a bit of a trick question because the secret ingredient is you. Yeah, and you, 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 and you. I need my audience. Now that sounds really sweet. Like, yes, I need an audience to watch the show. That's great. Sure. What I need is you because you are made of stuff. That may sound kind of strange to say that you're made of stuff. Who thinks that sounds kind of weird? So maybe we need to figure out what stuff is, right? So I want everyone to look at the stage. Do you see stuff on these tables? You think? Yeah. Yeah. Did you see stuff in the museum today? Yeah. Does anybody have stuff at home? What is stuff? It's kind of a hard word to define. Getting pretty deep. Like that. Okay. Well, we'll talk about those atoms a little bit later, so I'm glad you brought that up, because they are going to come to this show. But before we even get to those little tiny pieces, what's the name that we have for all this stuff, these things, these objects? Now, there's a word that we use, more scientific word, for stuff that takes up space, stuff that has mass or weight to it. Well, that's a state of this, the whole general term we use for all this stuff around us. Do you think it matters what we call this stuff? There you go, right? Because it's called matter. So all of this stuff around us is matter. You are matter. The air we breathe is matter. My shoes are matter. My nose is matter, right? Matter is all that stuff. Now, you mentioned something called solid. So I want to break that down into different states now, right? Let's try to specify this matter a little bit more. So we have three signs here. One that says solids that you mentioned. This one says liquid. There we go. And this one is gas. There we go. Okay. So here are three states of matter. And we have three of them on this in this room on this stage right now. Now, before we get in any further, you might have heard of other states of matter, things like plasma, things like that. The reason I don't have signs for those is because we don't get to deal with those ones as often as we do these three. So first, let's focus on solids. Are there any solid objects that you can see on the stage? Yeah. Is this table solid? What do you think? Let's test that. Ready? Yeah, feels pretty solid. Okay, do you think this wall might be solid?
Yeah.
Yeah, feels solid to me. How about my nose? You think that's solid? I like that. See, that always gets a nice reaction, a nice yes and no. Yes, my nose is a solid object. Okay, it's what we call a flexible solid. So, like my clothing, my skin, hair, things like that, these things are able to move. They're still solid objects, though. They still have some form to it. If I took off my nose, right, and dropped it in this glass here, it wouldn't immediately melt to take the shape. It'd be pretty gross, but it wouldn't immediately melt in there. Okay, we still have solid objects here, like my ears, my nose. So next thing we need then is a liquid, something that will take the shape of that container. So can anyone think of examples of liquids?
Water.
Water, right? Very important one. How about coffee? Is that a good one? It's another important one for some people. Okay, so soda, right? Cola, right? Things like that. So these are all examples of things you can pour on the ground, make a big puddle, you can drink, they'll take the shape of the container. Okay. Gases. Do we have any gas in this room right now? Ooh, bunch of them. Wait a minute. There might be some of it. So, all these gases we've named so far. Is air one single gas?
Oh.
It's a bunch of gases, right? All right, so let's talk about some of these gases we've mentioned already. Okay. Now, oxygen. Oxygen. The one that you've mentioned so far. Is oxygen important to the human body? Keeps us alive, right? But do you think that the air is mostly oxygen? Who thinks it's like mostly oxygen? Not too many people? Good. Okay, cool. Who thinks maybe like half the air is oxygen? Okay, who thinks like less than that is oxygen? Yeah, okay. So here's the thing about oxygen. Oxygen is very good for keeping the human body alive, but it's also very good for keeping something else alive. So let's take a look at this. All right. What do we have here? Fire. Okay, so this matches on fire. What we created was a combustion reaction. So three things had to come together to make this match burn. Fuel, which was the stick, heat, and then we needed oxygen in the air around us. So if I lit a match in a room that was full of nothing but oxygen gas, what do you think would happen to me?
Slow.
Should we test it? Here we go. 3, 2, 1. Yeah. Yeah. I would probably burst into flames, right? So that's why we don't want too much oxygen. It's very good for us to keep us alive, but it's also very good at keeping fires going and making explosions bigger. So we only have about 21% of our air as oxygen. That's it. Which means you've mentioned other gases, so there's plenty of room for other stuff. So you mentioned carbon dioxide too, right? Then we have things like water vapor and hydrogen and helium and argon that can all be squeezed into 1%. So that nitrogen that you mentioned is what makes up most of the air you breathe. So if we all take a deep breath right now, go for it. Take a deep breath. Go on. All right, let it out. Let it out. Most of what went into your lungs was just nitrogen. So if you're breathing mostly nitrogen gas, 78% of air is nitrogen. Is it poisonous?
No.
No, because you're breathing it. But can we breathe just nitrogen to stay alive?
No.
No, we need oxygen. Okay. Now, the whole room didn't explode, so I can see that nitrogen is definitely not flammable. And speaking of see, can we see nitrogen?
No.
No. Let's put all these things together. Boring. Nitrogen gas, it's kind of boring, right? Not dangerous, not keeping us alive, not flammable. So if we want to make this more exciting, we have to introduce the liquid part of the show instead of just the air. We're going to talk about a different state of nitrogen. Not the gas form, but something called liquid nitrogen. Now, who has heard of liquid nitrogen? Excellent, good. All right. I will call upon your past experiences with it. I would like to know more as we continue the show. But if you haven't heard of liquid nitrogen, that's totally fine. We're going to learn all about it during the show and how we can use it to introduce all of our states of matter. Well, here we go.
It's dry.
All right. So let's use our powers of observation right now. I can see a lot of mist, vapor, steam coming out of this glass. Can you see it bubbling in there?
Yeah. Yeah.
Okay. When was the last time you saw liquid bubble and steam like that?
Yesterday. I'm a tea.
Okay. Oh yeah, yesterday? Making tea. Wait,
Tea.
making what? Yeah, right. Sweet. What do we have to do to water to get it to look like that?
Boil.
Boil it, heat it, right? If we heat up water, we get it to boil, we see bubbles, we see steam. Now, when we think of boiling water, we tend to think of what, hot or cold? But who has heard of liquid nitrogen again? Let's see. Would you agree with me if I said it was super hot? Yeah. Maybe you've heard that liquid nitrogen is cold. So let's talk about this stuff, okay? Here's one thing that we can learn so far in the show. One thing that we can learn. By staring at this bubbling liquid, humans can't really see temperature that well. We don't see infrared light, so we have to use another sense if we want to tell the temperature of this stuff, right? Because it looks like boiling water, but I've heard it's cold. So I think we have to use another sense called what? Yes, we're going to touch the liquid nitrogen to see if this is cold or hot. People are shaking their heads. I shouldn't do that. Is that a bad idea? Exactly. If you see a pot of boiling water on the stove, should you test it with your finger?
No.
No. We've invented tools. Don't worry, we'll get to everything you're excited about. Trust me, don't worry. We'll talk about all that stuff. We're gonna get there. But we've invented tools to help us check temperature. So what tool can we use to check temperature? Yes. So we're gonna get a thermometer and we're gonna test this liquid nitrogen. Okay. So let me see. Here we go. All right. If I take my thermometer and I put my thermometer into this liquid nitrogen, you're right. Sorry. It's a little dark back there. Okay. Here's my thermometer. If we take the... Okay, hold on. All right. So I have two thermometers here. Okay. You know what? I'm going to be honest. I was hoping you would notice, but I totally forgot my thermometer today. But that's okay, because we're going to try a science experiment and we're going to see if these balloons can help me learn if this stuff is hot or cold. Well, it may seem kind of dangerous, but that's okay, because I am the safety trainer for the museum, which means I've put myself in a lot of dangerous situations so that you don't have to. So here's the plan. Here's what we're going to do. We're going to put this balloon into the liquid nitrogen. We're going to observe what happens to it. But before we do that, let's make some predictions. Now, this is a flimsy balloon made of latex, full of air. What are balloons very good at doing? Popping, right? Yeah. So who thinks this balloon might pop? There's a high chance, right? So I should probably point out the sign that says science can be noisy. I mean, I probably should have pointed this out a few minutes ago with that balloon, the first one. But right here, it's going to remind you that sometimes the show might get loud. So if you don't like loud noises, be prepared for a balloon that might potentially pop. But let's hear some other predictions. What else do you think might happen to this balloon? What do you think is going to happen? Okay, so it might pop, right? So we can say it's going to pop. What do you think is going to happen? Okay, so there might be too much pressure, like it might blow up a little bit too much and then explode. Ooh, okay, I like that. So it might grow bigger, get more pressure and explode. It could pop, maybe it'll get like a small hole in it.
It might stretch.
It might stretch. Right, if you put something into boiling water, maybe it's going to make it weaker and it'll stretch more. Great predictions, everybody. All right, well, are you ready to see what happens?
Yeah.
Here we go. I predict that nothing's going to happen. So here's the plan. All right, ready? 3, 2, 1.5, 1, go. Nothing happened. I mean, I kind of cheated because I knew I've done the show before. Oh, wait. Oh. Okay, maybe it did pop, but just not like quickly. Maybe it was just like a slow release of air. Hey, okay. Would this be a proper science experiment if I only did it one time though? No, we want to try it again and again, see if we get the same results. So let's try it with the orange one and yeah, same thing. There we go. All right, let's do this one. Here we go. Okay, same thing's happening. So it seems like every time we put a balloon into liquid nitrogen, the balloons just shrivel up and deflate. Now, that doesn't seem super impressive because I could just put a whole bunch of balloons into a cup and put tiny holes in them, let the air out. So I think the impressive part is what happens if I just throw these on the table.
Oh.
Now that these balloons have left the liquid nitrogen, oh no. They're alive. They reinflated, and I've never seen a balloon pop, lose its air, and then reinflate. Did you think we actually took any air out of those balloons to shrivel them up? No. So now this is where we get to talk about those atoms you mentioned, okay? Everything around us, these balloons, the air in those balloons, you, me, my nose, the liquid nitrogen, exactly. The wood that's on the table here, the seats that you're sitting in, the floor you're standing on, all this stuff is made of those little tiny, tiny things called atoms. Can I show you one atom? Yeah, see? Technically, yes. Like if you zoom in enough, maybe you could, okay, no. So here's the thing about atoms. They are so small that I have millions of atoms right here in the palm of my hand. So I cannot show you an individual atom. So instead, I'm going to have to make a model to show you what these things can do. This thing is called the Holman sphere. You might have played with one before. It's a neat toy. But I want you to ignore the purple and just pay attention to the green here. We're going to say that the green parts are the atoms that build up the air we breathe. First thing we have to do, give them energy. Okay, so we're giving them energy. We are heating these atoms. As they get hotter, they start to move faster. And the faster they get and the hotter they get, the further apart they spread. So you heat them up, you speed them up, and you spread them apart. And if you keep getting them hotter, they're going to keep moving further and further away. But wait, we also want to talk about cold. So if we get them colder, do you think they're going to keep spreading apart? Exactly. They're going to start to come closer. Okay, so as they get colder, the atoms themselves are not changing size, but the atoms are moving closer to each other. And they're getting colder, and they're moving slower, and they're getting closer together. I said, yes, let's heat them back up. Okay, we heat them back up, they spread apart. We cool them down, they come together. We heat them up, we spread them apart. We cool them down, they come together. We heat them up. Are we actually heating this thing up? No, okay. So this is a decent model, but let's find something even better. Let's use some actual heat. Let's create a fire here on stage. Don't worry, it's okay. It's okay. As I said, I am the safety trainer for the museum. Okay, so I know how to not be on fire. But since I am the safety trainer, I also like to elect a safety team to help me out. So is there anybody here who knows how to use a fire extinguisher? Okay, great, cool. So you both had your hands up first. Anybody in the back? Okay, cool. So here's the plan. So you're going to be my safety captains. Both of you, yeah. If I am on fire during the show, I will run to you for help. Backup safety team. If we are all on fire, we'll run to you for help. Okay, cool. All right, here's the plan. I feel so much safer now. Don't worry, nobody has ever been on fire for my show. Just me once. Okay, here we go. Fire on stage. And now, if you look closely, actually, before we look, I bet you're all jealous because I know it gets very cold in this room, and this feels really good. Okay, anyway, if you look right here, you're going to start to notice those atoms heating up. And we said that when atoms heat up, they spread further apart. So you should see the air getting. Can we see air?
No.
Right. So we're going to have to capture this air somehow. Here we go. Okay. This is a mylar balloon. Now, mylar, it's that same stuff that you see balloons, like birthday party balloons, made out of. It looks like foil. Now, this is empty, but it's full of air. So here's the plan. We're going to get that air hot. As that air heats up, it is, exactly. The atoms are spreading apart, they're expanding, and the balloon is growing bigger. So we're not pumping air into it, we're just getting those atoms hot. So just like we saw with our Holden sphere, here we go. If we heat up those atoms, they're going to spread. Sorry. So that's a really cool weather thing that we'll talk about a little bit later as well. But if you see, when they get hot, they spread apart. Oh, I got it. Okay. As you watch closely, you'll notice that the balloon is now deflating. Because as the air inside gets cold, the atoms come closer and closer and closer together. Okay. Whew. All right. Okay. So just like we saw with that balloon, let's bring that back to this balloon. We put this in the nitrogen and the balloon shriveled up. We took it out of the nitrogen, the balloon got bigger again. We got the air in here hot, balloon got bigger. The air got colder, balloon got smaller. When we put this into nitrogen, do you think it was getting hot or cold? Cold. And we can witness that now. We've watched how it cooled down the atoms in that balloon, caused that air to condense, and made that balloon shrivel up. We took it out, got warmer, spread apart. So we can see that our liquid nitrogen is indeed very cold. So if you knew it was cold, great job. If you learned it was cold, wonderful. But I'm curious, did anybody think that it was actually boiling? Because you'd be correct, which may seem weird, because when we think about boiling, we tend to think hot water. But boiling just means that a liquid is getting warmer, the atoms are spreading apart, and it's turning into a, Now, for water to do that, it has to get hotter than us. But since liquid nitrogen is so cold, the temperature at which it stops being liquid and turns into gas is way below anything we've ever felt. Introducing my temperature charts. If we look on this side, 32 degrees Fahrenheit. This side, 0 degrees Canadian. That's where we start to see really, what? Oh, you got me. There we go. Okay. Thank you. I knew that. 0 degrees Celsius, 32 degrees Fahrenheit. That's where we see water freezing. Do you think liquid nitrogen can be liquid at this temperature? No, because if you go outside on a really cold, snowy day and you breathe in, you're not drinking the air around you, right? So nitrogen gas has to get very cold to be liquid. So here we go. Ready? We're going to drop all the way down here. Boom, 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 boom. To negative 320 degrees Fahrenheit. That's about 400 degrees colder than your skin is right now. And I know this room is cold, but nowhere close to this cold. That number negative 320 degrees Fahrenheit, is the boiling point of liquid nitrogen, which means we have to get it even colder than that for it to stay liquid. There is nowhere on Earth, not here, not the North Pole, not the South Pole, not your freezer, that can be that cold. So there's actually no way I can keep liquid nitrogen for very long. In fact, the stuff I poured on the ground to let those balloons out, it's gone. It didn't leave a wet spot. Here, let me show you again. I have a little bit more left in here. If I just throw it on the carpet, we'll see how it quickly boils away into the air. Which means that nitrogen is spreading into the audience. And if you breathe in, you get a souvenir. Now, that's probably the only safe way I can give you nitrogen, because the cold stuff, as you can see, negative 320 degrees, might not be very safe for your skin, okay? And I'll show you a few other things about it that's really, really cool. Maybe how we can use it, but also how it can be kind of dangerous. Let's talk about pressure, okay? If I were to try to put this liquid nitrogen into, say, something that was not an approved nitrogen container, like a can of Pringles, it might not work out so well. So this device right here is called a liquid nitrogen dewar, and it is designed to hold nitrogen for a short time. This thing will hold nitrogen for an extremely short time. Now, if I tried to put a cap on this thing, try that again. There we go. Hold on. There we go. We got it. We got it. We got it that time. Oh. So as you can see, this Pringles can is not the best way to hold nitrogen because we mentioned that this stuff is constantly boiling, which means if the atoms are getting hot, what are they doing? Yes, right? Now, when that happens to liquid nitrogen, it spreads, those atoms will spread apart and expand about 700 times. Let's see how dangerous that pressure can be. This is a solid titanium tube. If I try to contain this with a solid titanium cork, it's just actual cork. But if you've worked with corks before, you know they can be really difficult to get out of a bottle. But if I just hammer it in like this, let me try a new one. Here we go. I hammer it in just like this. Uh-oh. You can see that we cannot hold this nitrogen for very long. Pressure builds up and it's going to escape from whatever you contain it within. Now, to show you just how much that's going to expand, we need something that's going to grow with nitrogen. So how about a balloon? A balloon is designed to contain gas, right? Which means this balloon will have to grow to 700 times its original size to contain all this gas coming from that nitrogen, which doesn't seem extremely safe because this balloon is a 9-inch balloon. It's only designed to get about like this big, and it's going to have to get about. I think we did something really dangerous here. Okay, I'm going to try to get this thing out of the plane right here. I'm just gonna take it and I'm gonna put it like right over here. How's that sound? No. Right. How about over here instead? Right here. Okay, we're gonna put it right there and we're gonna ignore it for a moment and hopefully that won't explode. I think it'll be fine. Okay, now here's the thing. I cannot get it out. Should I? Okay. Yeah, because I'm really scared. Where's my other glove? Oh, my other glove's in there. Oh no. Okay, don't worry, it's fine. It's fine. Yeah. See, totally fine. Okay. Okay. Well, so liquid nitrogen is extremely difficult to keep for very long. So I'd like to give everybody here a souvenir, but also a show. Okay. For those of you who are not here present with me right now, you can also get liquid nitrogen or just nitrogen from the air by breathing it in. So I'm going to see if we can create enough of this nitrogen to go all over this museum and this room. Here's how we're going to do that. We're going to have to pour the rest of the nitrogen, the liquid nitrogen that I have here in this container onto the floor, which may not be that exciting because as you can see, we get like a nice little cool cloud effect, but we want to make that bigger. So this is where the weather science comes back in. What did my balloon do when it got hot? Right, we got to watch it float into the air. When it got cold, it came back down. But if it gets hot again, do you think it'll go back up? This is called, you got it. That's what we call convection, okay? So convection is that process of heat going up, cool coming down, going over and over and over again. That's how water vapor and things like little droplets that we see in steam here, rises high into the air. Now, once that reaches our atmosphere, it's going to get cold. And those droplets will come back together, and we'll get to see a nice giant cloud. Now, since I have a lot of hot water here on the stage and a lot of cold stuff, if I mix them together, do you think we can make a massive cloud here on stage? Let's give it a shot. All right. So there we have our hot water. We can see a lot of steam in the air. So now we have a lot of water vapor around this bucket. I'm going to need to throw a whole bunch of nitrogen in there. So we're going to fill this up. And then mix them together explosively. You're going to be able to watch the cloud. And then take a deep breath to bring that nitrogen with you. All right, there we go. That's enough. Is everyone ready? All right, we're going to count down from 3 and make a massive cloud. 3, 2, 1. Okay. Whew. So now you can see we have our massive cloud, which means all of this water vapor has condensed, but the nitrogen I threw in there is now spreading around the room. And then that nitrogen is now flowing out to the museum, which is then flowing out into the city of Philadelphia, which is then going into our atmosphere. So in a way, no matter where you go, you'll be able to breathe in some of the nitrogen from the liquid air show. I think that's the safest way I can give it out as a souvenir. Now, if anybody has any questions about the show, feel free to hang out. I'll be here answering questions for a bit, so you can feel free to do that. Otherwise, thank you all so much for coming to the show. Thanks for watching. Have a wonderful day at the museum. We'll see you around.
That includes you in chat. So if you guys have any questions, you can put it in chat.
And I'll be here to answer those for you guys. I am going to bring the lights back up.
All right, guys, what questions do you have?
You guys.
Let's see what we got here. No questions about nitrogen? No questions about the air? Come on.
Any campers have any questions? Mr. Sheik is live, so he can ask any questions you may have. What percentage of the air is nitrogen?
So what percentage of the air is actually nitrogen?
78%.
78%, guys.
Wow. Okay, let's see.
You almost have, if you split up the air into 5 parts, you almost have like 4 parts of that as nitrogen gas. So most of what you're breathing is just nitrogen. So even though this may seem like dangerous stuff that I'm throwing around the room here, if it's in its gas form, it's safe to go inside your body. It's safe to breathe. This is stuff you're breathing all the time. But do you think that you don't need oxygen?
You definitely do need that.
Exactly. So you never want to stand in a very, very, very small space and pour a lot of liquid nitrogen on the ground, because it's going to push a lot of the oxygen out of the way. So you will need that oxygen too.
So
But, yes.
and Gabriella wanted to know, why does nitrogen steam? What makes it steam?
Okay. So let's play with what I have left here. Ready? The reason you're seeing what looks like steam is not actually steam at all. It's the same thing that you see if you go outside on a very cold day and you breathe out. What you're actually seeing is the water in the air turning into a cloud above it. So when you breathe out on a cold day and you see your breath, what you're seeing is our water droplets turning into a cloud on your breath. Because there's a lot of water in your body, right? In your mouth too. So if you cool it down, you get a cloud, just like in the sky, just like right here. So that's what you're seeing. You're just seeing a lot of water vapor turned into a cloud above this nitrogen. It's that cold, it's able to condense it.
So we had 2 other questions, and I think they might be together, kind of. So Emma wanted to know what happens what does your body do with nitrogen when you breathe it in? And then I believe, let me make sure I get the name right. It was Anna Lee wanted to know, is that why we have difficulty breathing depending on the altitude?
So actually, there are quite a few things that go into that. So the altitude one, yeah, because as you go higher, yeah, the air is getting thinner. So it could be a lot of that too is because, yeah, the higher up you go, the air is getting thinner. It's harder to get that oxygen in there. So it's kind of like a multiple. There are quite a few things going on there. It's one of those fun. Yes, you're correct, but also this answers, which is what makes like science education so much fun. Like every time you get one answer, there are like 20 other ones that 20 other questions that you create. So, but that's more about like oxygen and like how far apart, since you're moving far away from like the Earth's gravitational center there. Because do you know what keeps like air here on the Earth?
Does anybody know what keeps air here on the Earth? Anyone have any questions?
Our atmosphere?
Atmosphere?
Well, what's keeping the atmosphere here?
And what keeps the atmosphere here? Gabriella said gravity. Is it gravity?
Yeah, that's it.
Good
That's it.
job.
Good job.
Yeah.
Answers
So-
were gravity.
Gravity's keeping that air here on this Earth. As you go higher up, though, further away from the Earth itself, further away from the Earth's center, you're dealing with slightly less gravity, which means the air is getting thinner. That's where it gets harder to breathe as you go to a higher altitude.
And Isaac wanted to know, not necessarily a science question, but he wants to grow up to do what you just did. How long did it take for him what do you need to do to become a scientist?
Oh, cool. Well, so I like to think, so that's an interesting question too, because being a scientist doesn't always just mean like going to school for a long time and doing this and that. Being a scientist can be many things. Like you could be a scientist today. Like if you like to study things, if you like to build things, if you like to perform, like if you're curious and you're like, why did this thing work when I dropped it? Let me try dropping it again. That's being a scientist. So there are many ways to be a scientist. I like to say that what I do is a science teacher. You could be a scientist, but what I do is I'm a science teacher. I teach science, and my background was in education. So I actually started instead of like actually going into like a science field in school, I wanted to teach, and science is one of my favorite things to teach as well. So I got lucky, and I ended up at the museum teaching people how to like, from what I've learned from like other scientists and from other people I've worked with, how to turn that into something that everyone can understand.
So just like Mr. James and Miss G, all the people that you've been dealing with these past 2 weeks who are teachers,
Yeah.
That's how Mr. Fox got involved in this too, by being a teacher.
I was gonna say just Mr. Cleary.
Oh, Mr. Cleary, I'm sorry. I'm sorry, Mr. Cleary.
Yeah, I also have my background in science education too, so that's why.
I know, I was gonna say, we'll send Mr. Cleary in and you guys can have a powwow. That's
I'm sure we have a great
fun.
time. Liquid nitrogen is one of my favorite demonstrations to do too. I just never get a chance to mess around with it.
Yeah, it's definitely a favorite. And you said it's been around since the museum opened. Is that right?
So yeah.
Yeah, so that's great. There was one other science question, and we'll have time for maybe one more. Tristan and Grayson, and someone else asked this as well, like about the nitrogen exploded when it hit the hot water. You kind of explained that a little bit,
Okay.
but could you go into it again?
So one thing is, so by throwing into the hot water, there are like a few different things that are happening there too, because there's a lot of, because that water was so hot, we were creating a lot of steam there, which meant there were a lot of water droplets in the air and then a lot of water vapor around that. So the reason you got to see a lot of like clouds suddenly form was because it was cooling down that water. But the reason for the explosion was because of the way I forced the nitrogen into the hot water. So remember how we saw the Pringles can? Here we go. Where's the lid? So when we watched the Pringles can pop, that was because we were containing that nitrogen. So I'm going to put a little bit in there, and we'll run that experiment one more time. Oh, there we go. So since nitrogen is boiling, it's returning to its gas form, the atoms are spreading apart. If you try to put it inside anything that doesn't have a way for it to come out, it's going to explode. So that's why you never, ever want to put it in anything that can screw closed, because that will still escape.
By the way, just to make it topical,
Yeah, what's that?
how many of you in chat are going to be barbecuing on the 4th of July?
Ah, nice.
So, and I see a couple people raising their hands. If you ask your mom or dad or whoever's doing the grill about when they light the grill, you always have the lid open for that exact reason.
Go.
It's the same thing. You don't want to trap gas because gas will escape.
Right. Especially with a combustion thing like that too. Heat, remember, heat expands. Boom. But for this, since I threw that cold nitrogen into that hot water, some of it went under the hot water. And as we've seen here, nitrogen doesn't like to get trapped. So where do you think it pushes that water? In fact, if you want to come up on stage, yeah, you can. What's what it did to my table here?
Wow, that's
Check out like all that water escaped onto the stage, onto the floor, onto the table. There's still some in the bucket. But yeah, by throwing it into that hot water so fast, it covered it, part of it, and threw all that water to the air, creating that massive explosion. And that cloud came from it being so cold.
all right, guys. Time for one more question. We're going to ask one more question. Who else has another question? And I'll tell you, if everybody else does end up with questions as well, and you email me, I'll make sure. Mr. Fisher's has been helping us out too, who we haven't seen. Say hi, Mr. Fisher. He's going to make sure that Mr. Fox gets some questions from you guys as well. So that's, oh, go ahead. I'm sorry.
Happy to answer questions. I love doing it. So yeah, if you guys have, feel free. Like my favorite thing.
All right. So anyone have any more questions? Seems like they might have answered quite a few.
There's one last thing that I usually don't show audiences if you want to see something really cool.
Yeah, of course we want to see something really cool.
Okay, advanced science, ready? So I usually like to say, don't try these things at home, right? Because these things can be pretty dangerous. Now, one thing I don't always like to show off to audiences, you might have heard that liquid nitrogen is so cold. If you touch it, you'll get frostbite. But if you want to get into some really cool advanced science, if anybody likes to cook, there's something called the Leidenfrost effect. So if you drop like cold water onto a hot surface like a stove, there's a few seconds where you see it skitter around. It's because you're creating like a little tiny gas barrier in between the droplet and the hot surface. But if my hand is supposed to be about like 80 degrees Fahrenheit, I mean, this room's kind of cold, so somewhere around that. Liquid nitrogen is liquid below negative 320. If this accidentally gets on my skin, as long as I make sure it doesn't stay there, I'm okay. So that's what we call the Leidenfrost effect. And it's why when you see me doing the show, I roll up my sleeves. I would rather have it slide off my skin instead of soaking into my clothes. Now, does that mean that you should play with liquid nitrogen? No. But as the safety trainer, I always like to say, don't be afraid of it, but respect it. Because if you don't know how to work with it, it's going to hurt you. But if you do, little tiny splashes are okay.
Couple kids asked us this one question. I think this is just more about you. A lot of kids say thank you, by the way.
Of course. Thank you guys so much. I appreciate it.
Loved it.
Yeah, but a lot of kids notice that you paint your nails. Is that just like a fashion statement, or is it still more of a science thing?
Several things. It's more of a fashion thing, but it's also, since I spend a lot of time up on stage, sometimes people like to. I actually started doing it because we had a visitor who came here years and years ago, about 5 years old, and he was painting his nails, and he thought it was really cool, but he was like, oh, I don't see anybody else doing it. I was like, I'll do it too. So I've been doing it since then, and every week I like to ask, like, what color should I do next? And since this week is almost over, what color do you guys think I should do next?
Yeah, what color should Mr. Fox paint his nails next?
Orange for PA virtual.
Orange?
Miss Heather doesn't get a vote.
Okay.
Sophia says silver. Tristan says blue.
Blue.
Oh,
Okay.
blue might be good for 4th of July. Okay, I see where the campers are going.
Yeah, okay. I didn't even think about that.
Yeah, Abby mentioned red as well, but I think
Okay.
4th of July we've had about 6 votes for blue, so I guess it's going to have to be blue.
Okay.
All right.
Bellamy, I think, wants you to get fancy. She said, "Why don't you put some stars there too while you're at it?"
White and
I'm not the
blue.
best
stars.
artist, but I'll do my best. Yeah.
All right, camp directors, did you have any questions as well, real quick, since we're here?
I don't believe so, but we just want to say thank you so much. The kids were super excited in chat. They had a whole bunch of great things to say. All of them said how much they loved our time with you today. So thank you so much. We very much appreciate it.
Of course. Thank you so much for being here.
Thank you. It was wonderful.
So much
Yes.
fun.
We have
And
one
real-
person who is actually at the Franklin Institute, and they're just wondering where exactly you guys are. So I can just tell them where to meet you. So
So we're up on the third floor. We did have someone that was here. Emma and her two children were here, and they were walking around. But we're up on the third floor. I'm going to be here for a few more minutes before I kind of head out and stuff. But I did want to remind everybody too. One, they do a combustion show. We're talking about combustion and explosions here at the Franklin Institute as well that you guys can kind of check out too. And if you want to check it out, yes, Mr. Sheik still has Franklin Institute tickets that your parents or grandparents, whoever's with you know. Just email Mr. Sheik and he'll mail out some tickets for you. We want as many people as possible to come out here, see this stuff live, because I'm seeing in chat, people want to become scientists, and that's what we want. We want you guys to really be involved because most importantly, all week you guys have been scientists. You guys have been scientists in the kitchen. You've been scientists learning about your bodies. Yeah, I've learned stuff from you, and you could just learn a whole lot more by going to places like the Franklin Institute. That's why it's here.
thank you so much. We appreciate it. Have a wonderful weekend.
All right, y'all. I'm going to turn off the camera. Anyone who happens to still be at the Franklin Institute and maybe just streaming this, I'll be up on the third floor for a few more minutes. And camp directors, you guys take it away.
All right, Mr. Sheik, thanks so much. Have a great afternoon.
Yes.
All
thank
right,
you
y'all
for the
too.
presentation.
All right, campers, if you just want to stay on, I just want to wrap a couple things up. What did we think about that presentation? Oh my goodness, what a great week. I'm so glad that you guys are so interested in Science Week. Thank you so much to Mr. Cleary. He did an amazing job. We were super interested in all of his lessons. We did some wonderful experiments. If you guys took any photos of your experiments and you want to share them with us, send them my way, or you can send them over to Mr. Sheik. I'm going to give you the email address to the front desk only because it's the easiest one to remember. So if you want to send us your photos, you can send them to info@pavcs.org, and then I will get them and I can share them. Just a couple more things. Don't forget to fill out those passports. We're really looking forward into sending out some prizes. I have about 20 of them that I've already received. If you've already filled out 6 sessions, make sure you fill out for 12 and 18. We will be getting those out. Just a reminder that this was recorded, so we're going to just do some slight edits, and then it will be up on our YouTube page if you want to review it or if you want to share it with any friends that weren't able to make it today. And then don't forget, we will be back next week. We have off Monday and Tuesday, but Wednesday we will be back with Olympic week. So just check for your emails. We'll send out an email detailing what we're going to do next week, any supplies you might need for some activities. And if anybody wants to stick around, if you're not a PA virtual family and you have questions, I will stick around to answer any questions you may have. But otherwise, campers, thank you for completing your second week of PA virtual summer camp. We were so happy that you guys attended, and we'll see you all next week. Thanks so much. Bye, Mr. Cleary. Thank you again.
Yeah, bye. I'm glad to see that a lot of you had a great time. I had a great time leading the activities here.
Yes, and you guys have some great stuff to take to picnics. A lot of great things that you can share with your family and friends. Thank you so much, everyone. Enjoy your weekend.
Have a great weekend and have a good 4th of July.
You too. Enjoy your time with Dexter. I'm sure he's going to have a great 4th of July.
Oh, yes, he's getting hungry. It's about time to feed him.
Yeah. Take care. Bye, guys. See you later,
Hi,
campers.
everybody. See you guys later.
If anybody's going to stick around, just let me know in chat so I know to wait around for you. And then if not, then I will see you guys next week. Okay. Bye. We don't have sessions on the 3rd and 4th of July. We will have sessions starting next Wednesday again. So feel free to watch the YouTube channel on Monday and Tuesday. We have some videos up from last year, summer camp. We're putting them up from this year. So we will also be sending out that reminder that, we'll be off for those 2 days and then what to expect next week. William and Isaac, I'm so glad you guys had so much fun today. We've had a great summer camp the past 2 weeks. I'm super excited for the next few weeks that are coming up. We have a lot of great stuff planned. So if you know of any friends that haven't joined yet, let them know, because we're going to be here for a few more weeks with lots of fun stuff.